Alright, this is lesson 7.6. 7.6 is the last one before your test. So your test is going to be on 7.4, 7.5, and 7.6. Alright, everybody pay attention, please. Guys, this one's probably the easiest lesson that we've had this whole chapter. All we're doing is determining whether the shapes are enlarging or reducing. Okay? So, from A, so right here it tells you where to start. From A, so that means we're starting at A, and we're going to B. Is it enlarging or did it reduce? It enlarged. Good. So B is larger than A, so the dilation, the change, is an enlargement. So we need to determine enlargement or reduction, and the second thing we need to determine is the scale factor from A to B. So here's how this works. You just told me, this stands for scale factor. You just told me that the largest, it went from small to large, right? So if it is enlarging, then the largest shape goes on top of the scale factor. So find anywhere where you can count the number of boxes. So from A and B, I would count the bottom or the top. They're going to be the same. So what is the length of this bottom piece of B? How many squares are there? 1, 2, 3, 4. Good. 4. And how many for A? So what is your scale factor reduced to?
2.
Yep. 2. So if it is enlarging, this one was an enlargement. So when you find the scale factor, you put the big one over the small.
And vice versa.
And vice versa. If it's a reduction, you put small over big. Same thing. We're going from A to B. So we started off with A, and then obviously it shrunk to get B. So this is a reduction.
So we got to put the smallest on top.
Very good. Count the number of boxes. I would count this side. So for B, you have 1, 2, 3. So it is a reduction, so you need to put the smallest shape over the largest shape.
You get 3 over 6.
3 over 6. What does that reduce to?
Like
As a fraction, what does that reduce to? 1
1/2.
half.
Oh, dang, I'm so smart.
Simplify it, okay? Very good.
Can we turn it into a decimal?
No, leave it as a fraction. All right, let's try 1 and 2 together. Determine the dilation from A to B. So which one was my original figure?
A.
A to B. So for number 1, it got bigger. So it's called an enlargement. So when I'm finding the scale factor, the largest shape goes first. 4, 5, 6. 6 over 3, which is equal to 2.
Oh.
It's all right. Your Aspire score went up.
Yeah. Good job.
Second one, starting with A. So which way did it go? From A to B. Reduction. Good, Justice. So that means which one of these goes on top for the scale factor?
B.
Smallest. So I'm going to count the top boxes. The smallest one has 3. The bottom one, or the large one, has 3, 4, 5, 6, which reduces to 1/2.
Same as everyone is.
I know. Different shapes, though. All right, y'all try 3 and 4. Y'all think this is good? Not bad? It's kind of easy?
Reduction.
No, leave it at that.
So, what is it? What's the fact?
David, I'm coming. Please chill for a second.
Is that right?
Okay, tell me if it's a reduction or a enlargement.
Will you go ahead and tell them back?
Yeah, good job. Good job. Good job. Good job. Wait. From A to B. Did it get bigger or smaller?
I'll leave the second one as it is.
From A to B. Starting here, going there. Did it get larger? Did it get smaller? Smaller. Because the top is 4 here, top is 3 here. Because the instructions say from A to B.
If it's 4 over 3, do you want us to just keep it as that?
It shouldn't be 4 over 3.
Huh?
Alright, number 3.
I want to do it. I'm talking about the back.
Leave it like that. Eli, reduction or enlargement for number 3? Reduction. So the smallest one goes on top. What was the scale factor? What, Angel? 4 over 5. Okay, good. So from A to B, it was a reduction. So the smallest one goes on top. 4 over 5. All right, number 4. Kevin, enlargement or reduction? Yep, reduction. And what was the scale factor? How many is on the smallest one? 3 over what? If you count the top here, 1, 2, 3, over the top of this one, 4. Good. That's all it's got to it. So on the back, let's do number 5 together first, because this one's just a little bit different. So the first thing you need to do for number 5 is actually graph the shapes yourself. So go ahead and start putting these points. So -3 up 4. If you only have 3 points, it's probably going to be a triangle. Yes, ma'am. So one quick thing about how this is written. A, do you see how there's A and then there's A prime? That's how that little, that's called a prime. So A, if there's no prime beside it, it's just A. That tells you that that was the original. And wherever there is a letter with a prime, so A prime, that means that's the dilated version. Okay, so the original was actually the first one. So the big one was A, and the small one's A prime. So is this an enlargement or a reduction? Reduction. Now it doesn't matter which part of this triangle you count the boxes. I would not count this part because that's not actually going through squares. I would count either the top or the side. Doesn't matter which one, just be consistent. So if you count the top for one, count the top for the other. It's a reduction, so which one goes on top? The A prime, good. So 2 over 6, which reduces to 1/3. Have y'all heard of that terminology before? A prime?
Nope, but now I do.
All right, good. So the top 4, you're just doing like we did on the other side. And the bottom, you just need to graph them and then do the same thing.